welcome back. Today is day 6 of our exponents unit. Today we are finally getting to the applications of exponential equations. So basically this is, why do we have to do what we've done and where does it take place? Well, the most familiar place you see these types of problems is in a simple interest problem. And this is our interest formula. When I've seen these questions on the Regents exam, they always give you the formula. They're not on your green sheet, your formula sheet, and you don't have to memorize them. Like I said, anytime I've seen them on the Regents exam, they've been given right in the problem. A is our final amount. A sub 0 is our initial amount. This is what we're starting with. R is our interest rate as a decimal. So they'll do it to a lot of times as a percentage, and you need to change it into a decimal. And T is the time that you invest. We also have compound interest. And again, we have A, which is our final amount, and A sub 0, which is our initial amount. We still have R, which is an interest rate as a decimal, and T is for time. This time, the newest variable is N. And N is the number of times per year. When you have compound interest, it can be monthly, it can be yearly, it can be daily, it can be semi-annually, which is twice a year. It could be, weekly, anything like that. So N is just the number of times per year. And the last interest formula we have is continuously compounded. When it's continuously compounded, we have A equals your final amount, A sub 0 is still your initial amount, R is your interest rate as a decimal, and T is the time. But notice we have E in this equation. Okay, E is that number that we talked about yesterday in the graphic, 2.718, and it goes on. It's just an irrational number. When you're doing these problems, you're definitely going to need your calculator, and you're using the E button on your calculator. Continuously compounded, this formula here is also used for the half-life problems, or half-life decay problems. So this is used for half-life decay of an element. Sorry, this is getting in trouble. There we go. So we have a couple of examples to try today. And with these examples, first I have to determine which formula I'm going to use. And after I determine which formula, I'm going to label all of my variables and what they are. So Amanda won $10,000 and decided to use it as a vacation fund. Each summer she withdraws an amount of money that reduces the value of the fund by 7.5% from the previous summer. How much money will the fund be worth after 10 withdrawals? So this is just a simple interest because it doesn't give us the number of times per year. It's just saying that she's going to withdraw 10 times. So it's happening once a year. So we're going to use A equals A sub 0 times 1 plus R to the T. And in this equation, A sub 0 is my initial amount, my starting amount. My starting amount was $10,000. R is my interest rate. Well, my interest rate is 7.5%, but I need that as a decimal. And something else that's really important is the fact that she's withdrawing her money. And if you're withdrawing, that means your value is going down. So that means my rate is a negative. and then change 7% to a decimal, 0.075. And then T is the number of years. Well, if it's each summer, if she's taking out money, and they want to know after the 10th withdrawal, T is 10. So, the equation is actually going to look like this once we substitute in. A equals 10,000, parentheses, 1 plus R is a negative 0.075 to the 10th power. Now I have to work with inside the parentheses first. So 10,000 times 1 minus 0.075, so plus a negative, to the 10th power. And when I actually subtract inside my parentheses, I will get 0.925 to the 10th power. So, at this point I have to put it into my calculator. So on your calculator you type in 10,000, parentheses, 0.925 caret 10, close the parentheses. And whenever we're talking about money, we always round to the nearest cent, unless we are told otherwise in the problem. And in this case, once you type all of this into the calculator, you will get $4,585.82. So after 10 withdrawals, she will be down to $4,585.82. Okay? Next problem. In a state park, the deer population is estimated to be 2,000 and increasing continuously. Well, it's increasing, which means our R is positive, and continuously tells me I'm going to use the formula that says continuously compounded at a rate of 4% per year. If the increase continues at that rate, what is the expected deer population in 10 years? Remember I said this is when we use compounded continuously because they actually say continuously in the problem. That's our clue that that's the equation we're going to use. And this would be A sub 0 E 3 R T. And remember, E is just a number. So in this problem, A sub 0 is my initial amount. So my starting population is 2,000 deer. We have 2,000. E, jumping ahead here, 2,000, and then E is a number. R is my rate as a decimal. If it's 4% as a decimal, 4% is 0.04, and then T is 10. So A equals 2,000 E to the RT, so 0.04 times 10. So my next step is to actually multiply my exponents first. So I have 2,000 E 0.04 times 10 just moves the decimal point over one, so 0.4. This is where it becomes a calculated problem. So it's 2,000 parentheses. And you're going to have to find the E button on the calculator. It's above the LN button, near the log button somewhere, usually on the left side of the calculator. It will be E. When you type in E, you get a caret and parentheses. We're going to put in 0.4, close parentheses, close the parentheses again. And when we do that, we'll get 2,984D. Now you cannot have half of a deer, so you always have to round up. And are a person, so you always have to round up. With this type of problem, if it was a decay, you would have to round down, typically. And number 3, the decay constant of radium is negative 0.0004 per year. How many grams will remain of a 50-gram sample of radium after 20 years? Anytime you see a question that says decay constant, okay, this is a half-life, so we need to use A equals A0E to the RT. Because something that's decaying like this, like an element, will decay continuously. It doesn't stop after a certain amount of time. It will only decay during the day, or only decay at night. So my starting amount in this case is 50 grams. My R value is actually given to me as a decimal. So this one I can just copy right from the problem. Negative 0.0004. And then T in this problem is after 20 years. So A equals 50 E negative 0.0004 times 20. So I need to multiply in my exponent first. So you get 50e to the, when I multiply, I will get negative 0.008. Now this becomes a calculator problem. So it's 50 parentheses E caret parentheses negative 0.008 close parentheses close parentheses. And in this case, it doesn't tell me what to round to, but we're going to go to the nearest tenth. So it is 49.6 grams. So obviously this is one of our radioactive type of elements. And after 20 years, only 4/10 of a gram has gone away. So it just shows you how long it takes for radium to decay. So again, just to review our formulas, we have 3 types of formulas. We have a simple interest formula, which we're just talking about a final amount, an initial amount, an interest rate as a decimal, and time. And we have a compound interest rate, which we did not do an example of in here, but this is the formula you do, and you do need to follow your order of operations. You must divide R by N first, so whatever your rate is divided by the number of times per year you are compounding your interest. So whatever that value is, plus 1, and then you have the NT. So you have to do work inside first. divide, add 1, multiplying your exponent, then you're going to raise to the exponent and multiply it by the initial one. Alright, this is our last day of notes for this unit. Tomorrow is Wednesday. So Wednesday we will be doing some of these problems in class. Wednesday night's assignment is not a video so much as it is to get a chance to copy print out the review sheet, start working on the review sheet Wednesday night and use a video. And coming Thursday, if you have any questions, you'll be working with partners and you get to see the answers before you leave. Thursday night, I will have a video for you with the review on it. So if you have any of the last minute questions, you can go back and watch the video and see how I solved any of the problems that you didn't quite get. And then Friday is your actual test. So, good luck, and we'll see you in a couple days.